For more than 50 years, the moon has waited in silence. Since the final Apollo mission in 1972, no human has set foot on its surface. We looked up, we dreamed of going back. But for decades, the technology, the funding, and the global will just weren't there. Until now. The world is witnessing the start of a new space age, not driven by competition, but by collaboration. NASA, together with SpaceX, Blue Origin, and space agencies from Europe, Japan, and Canada, has launched the most ambitious lunar program in history, Artemis. Its goal is clear: to return humans to the moon, and this time, to stay. It's not about flags or footprints anymore. It's about building a long-term presence, developing technology that can keep astronauts alive for months, and learning how to live beyond Earth for the very first time. Because what begins on the moon will shape the future of humanity across the solar system. Named after the twin sister of Apollo, Artemis, it represents not just a mission, but a new philosophy of exploration. The Artemis program was launched by NASA to bring humanity back to the lunar surface, this time through global cooperation and sustainable technology. The journey began with Artemis 1 in 2022, an uncrewed test flight of the powerful SLS rocket and the Orion spacecraft that will one day carry astronauts farther than ever before. The mission was a success, a full lunar orbit, and safe return to Earth. Next comes Artemis 2, scheduled for 2026. It will send 4 astronauts on a 10-day mission around the moon, the first humans to travel that far since Apollo 17. Then, Artemis 3, planned for the late 2020s, will attempt what no one has done in half a century: a human landing on the lunar surface. But this time, the crew won't stay for just a few hours. They'll live and work on the moon's surface for days, testing systems that will one day support permanent habitats. It's not just NASA's project anymore, it's a coalition. The European Space Agency, Japan's JAXA, the Canadian Space Agency, and even private companies like SpaceX and Axiom Space are all part of this new chapter. Together, they're building the technology, the transport systems, and the courage needed to make humanity a multi-planet species. This isn't a race to the moon, it's the beginning of staying there. The moon is huge, over 38 million square kilometers of untouched terrain. So why go to the South Pole? Because it's one of the most extraordinary places in the solar system. Near the pole, sunlight never truly disappears. Some ridges remain illuminated for up to 90% of the lunar year, a near constant source of solar energy. Just a few kilometers away, deep inside ancient craters, the light has never touched the ground. These shadows are so cold that ice can survive there for billions of years. In 2009, India's Chandrayaan-1 spacecraft made a groundbreaking discovery: signs of frozen water trapped in those dark regions. NASA's Lunar Reconnaissance Orbiter later confirmed it: real, measurable water ice, hidden beneath the dust. For scientists and engineers, this changed everything. Water means air to breathe, fuel to launch, and life to sustain. It turns the South Pole from a place of mystery into a gateway for exploration. It's the only location where humans could build a base that produces its own resources, a place powered by sunlight and sustained by ancient ice. This is why Artemis will go there first, because at the South Pole, survival becomes possible. For decades, scientists suspected there might be water on the moon, but no one had proof. That changed in 2009 when India's Chandrayaan-1 orbiter detected signs of hydrogen near the lunar poles. NASA quickly followed with its LCROSS mission, sending a probe to crash into a permanently shadowed crater. The results were undeniable. Plumes of dust revealed the chemical signature of frozen water ice, hidden beneath the surface for billions of years. It was one of the most important discoveries in modern space exploration, because water changes everything. With water, astronauts could drink, breathe, and even create rocket fuel by separating hydrogen and oxygen. It meant the moon could one day become a refueling station for deeper missions, even to Mars. It turned the moon from a dead rock into a place of opportunity. Since then, multiple missions from NASA, India, Japan, and Europe have confirmed and mapped these icy deposits in more detail. And today, new orbiters are still scanning those same craters, searching for the safest, most accessible spots to one day extract it. This discovery didn't just change science, it changed humanity's plan for the future. Returning to the moon isn't just about rockets, it's about building the tools to stay there. Over the last few years, NASA and its partners have been developing an entire ecosystem of technologies designed for long-term survival. The first key player is SpaceX. Its massive Starship human landing system will transport astronauts and heavy cargo directly to the lunar surface. It's being tested right now in Texas, a vehicle larger and more powerful than anything that's ever flown before. On Earth, another revolution is taking shape. NASA and the American company Icon are working on Project Olympus, a plan to use 3D printing with lunar regolith, the dusty material that covers the moon, to build shelters directly from the surface itself. No need to bring bricks from Earth, the moon provides its own. At the same time, robotic rovers are being designed to scout, dig, and even help build the first structures before any human sets foot there. And for power, NASA is testing Kilopower, a small nuclear reactor capable of producing reliable electricity for years at a time, even through the 2-week lunar night. None of these systems are on the moon yet, but together they form the blueprint for the first sustainable lunar outpost. Each one brings us a step closer to transforming science fiction into reality. The first lunar habitats won't look like the sci-fi bases we see in movies. They'll be simple, compact, and built for survival. Right now, NASA and Icon are testing 3D printed prototypes here on Earth, structures made from simulated lunar dust, hardened layer by layer by robotic arms. These habitats are being developed under the project known as Olympus, a collaboration between NASA, ICON, and BIG Architects, the same team that designs futuristic cities on Earth. Each module is shaped to resist radiation and micrometeorites. Thick, curved walls help block cosmic rays, while interior layers regulate pressure and temperature. Instead of glass windows, high-definition displays could project the outside world in real time, a psychological bridge between isolation and the vast lunar horizon. Inside, astronauts will have compact living areas, scientific labs, and emergency shelters. Everything will be connected through pressurized tunnels to form a small but functional network of life. These prototypes aren't on the moon yet, but they're already being tested at NASA's Johnson Space Center to study how they'll behave in real lunar conditions. Step by step, humanity is learning how to turn dust into shelter. Life on the moon will be unlike anything humanity has ever experienced. Astronauts will live inside pressurized modules, sealed environments that must recycle air, water, and waste with perfect efficiency. Every system will be monitored around the clock, because up there, a single failure could mean the end. The crew will follow a strict routine: daily system checks, maintenance, scientific experiments, communication with mission control, delayed by seconds across space. Their food will come from prepackaged meals and small hydroponic systems where vegetables can grow under artificial light. No fresh air, no weather, no night or day. Only the constant hum of machines keeping them alive. To stay healthy in 1/6 gravity, they'll exercise for hours each day using resistance machines, fighting the slow decay of muscles and bones. Outside, they'll explore in next-generation spacesuits designed by Axiom Space and Collins Aerospace, lighter, more flexible, and built to handle the moon's harsh terrain. Every mission will last only a few weeks at first, but each one will test the systems, the psychology, and the courage needed for longer stays in the future. Living on the moon won't be easy, but every step, every breath will teach us how to survive. not just there, but anywhere. On the moon, power means survival. Every breath, every drop of water, every signal to Earth depends on it. That's why energy is one of the most critical challenges for Artemis. At the lunar South Pole, sunlight is almost constant. Certain mountain ridges, known as peaks of eternal light, receive sunshine for most of the year. These will become the sites for large solar arrays, designed to generate and store electricity for the base below. But when the long lunar night comes, a period of darkness that can last up to 2 weeks, solar power won't be enough. That's where Kilopower comes in. Developed by NASA, this small nuclear reactor can quietly produce steady energy for up to a decade, using only a few kilograms of uranium. It's compact, efficient, and capable of powering habitats, life support systems, and communication networks, even in complete darkness. Tests on Earth have already proven its reliability, and the first operational units could reach the moon before the 2030s. Alongside this, engineers are developing energy storage systems, batteries, and fuel cells designed to handle the extreme cold and heat swings that would destroy most electronics on Earth. Together, these technologies will make the moon's first base not just livable, but sustainable. Because in the darkness of space, power isn't just electricity, it's life itself. Building a base on the moon sounds simple on paper, but in reality, it's one of the hardest things humanity has ever attempted. The environment is brutally unforgiving. There's no atmosphere, no magnetic field, no protection from radiation or micrometeorites that strike the surface every few hours. The temperature swings are extreme, from over 120 degrees Celsius in sunlight to below -170 in darkness. Then there's the dust. Lunar regolith is sharp like glass. It clings to everything: spacesuits, seals, instruments, and can even damage lungs if it gets inside a habitat. Every system must work perfectly, because unlike the International Space Station, help can't arrive in a few hours. If something breaks on the moon, astronauts will have to fix it alone. And beyond the technical challenges, come the political ones. Who owns the moon? Who controls its resources? The Artemis Accords, signed by dozens of nations, are meant to ensure peaceful cooperation. But as more countries and companies set their eyes on lunar resources, tensions could rise. The dream of a permanent base is real, but so are the risks, and overcoming them will test not just our engineering, but our humanity. The moon is more than a destination, it's a beginning. Every tool designed for Artemis, every habitat tested, every system that keeps humans alive off Earth is a step towards something far greater: Mars. Before we can live on another planet, we have to prove we can live off our own. The moon is our test bed, close enough to reach, but far enough to challenge everything we know about survival. The lessons learned there, how to build with local materials, how to recycle air and water, how to stay healthy in isolation, will shape the first human missions to the Red Planet. In the coming decade, what begins on the moon will expand into deep space. Lunar bases will feed Mars ships. Moon-mined fuel could power interplanetary travel. And humanity's next home may rise from the same dust that once reflected our dreams. For the first time in history, we're not just looking at the moon, we're preparing to live there. And from that small world in the sky, our next journey will begin toward the stars.